FIA just confirmed the most radical rule changes in F1 history, and every team is on the edge of panic. Active aerodynamics replacing DRS engine rules turned upside down. And some cars may not even make it to the grid in 2026? This isn't just technical. Drivers are fuming, teams are split, and one regulation could end careers or reshape who wins for the next decade. F1 will never be the same. Stay ahead of the chaos. Hit that subscribe button now before the 2026 grid is completely unrecognizable. The FIA has officially confirmed the most aggressive regulation overhaul in modern Formula One history. These aren't tweaks, they're seismic shifts that will redefine how cars are designed, how drivers race, and how teams survive. Active aerodynamics will replace traditional DRS systems, power units are being re-engineered from the ground up, and sustainability is now more than a buzzword, it's a rule. With the announcement now public, teams have no choice but to adapt, or risk collapse before 2026 even begins. What's causing the stir is the scope of these changes. Active Aero, once a theoretical talking point, is now fully mandated for 2026. Front and rear wings will dynamically shift in real time, not just in straights like DRS, but mid-corner, under braking, and even while defending. The goal? Create closer racing without artificial tools. But the risk? If teams fail to perfect this tech, they could suffer catastrophic losses in downforce or straight-line speed. This isn't evolution. It's total reinvention. The power unit revolution might be even more controversial. The FIA is slashing internal combustion power by nearly half down to 400 kilowatts while doubling the electrical deployment to 350 kilowatts. That's an unheard of balance. For reference, these new engines will be 50% electric and fully reliant on 100% sustainable fuel. That may sound futuristic, but for engineers, it's a logistical nightmare. Energy recovery systems must now handle a load never seen before in racing history. All of this is being rushed into development on an unforgiving timeline. Teams are barely finishing their 2025 Aero programs, and now face an impossible dual task: run their current cars while designing a 2026 machine with unknown handling traits, brand new software algorithms, and powertrain dynamics that no simulator can fully replicate. Even powerhouse outfits like Mercedes and Red Bull are struggling to balance resources. Smaller teams? They're on the verge of being left behind entirely. The paddock's reaction is split. Some engineers see opportunity in chaos. Others are terrified. The regulations remove many of the old crutches: no more over-reliance on DRS trains, no more ICE-powered dominance, and no more exploiting loopholes in outdated fuel tech. Instead, teams are being forced to build smarter, lighter, and more adaptive machines. This shift isn't just about performance, it's about identity. The team that best redefines itself will win. Everyone else will be exposed. Drivers, too, are preparing for a different kind of challenge. No longer will races be won purely through tire management or ERS bursts. With active aero constantly shifting balance mid-corner, and electric deployment playing a larger role than ever, driving style must evolve. Mistakes won't just cost tenths, they could trigger instability or loss of energy recovery. Veterans like Hamilton have praised the ambition, but behind closed doors, many drivers are bracing for the most difficult cars they've ever handled. And now that these changes are confirmed, the countdown begins. Every day lost in 2025 is a day of risk for 2026. Teams will have to choose between short-term performance and long-term survival. The FIA's message is clear: adapt or perish. And for the fans, one thing is certain: Formula One in 2026 will be nothing like what we've known before. The race to reinvent has begun, and the grid may never look the same again. Active aerodynamics is no longer a prototype gimmick. It is the future of Formula One, and in 2026, it becomes law. The FIA's final regulations mandate that front and rear wings be capable of dynamically adjusting based on track position, car speed, throttle input, and even proximity to rivals. This isn't just replacing DRS, it's transforming the way cars breathe, brake, and corner. Engineers are no longer tuning for static downforce. Now, they're programming movement, anticipation, and adaptability into every aerodynamic component. This shift redefines how downforce is managed. Instead of a fixed balance, 2026 cars will have a constantly shifting center of pressure, controlled by onboard systems reacting in real time. The front wing may flatten on entry and re-engage under load. The rear wing could rotate mid-straight to reduce drag, then slam back into high downforce configuration in milliseconds. Teams that master this choreography will gain massive lap time. But those that miscalculate? They'll face instability at high speeds and unpredictable tire wear, a nightmare scenario. Strategically, it means teams can now weaponize their aerodynamics in new ways. Overtakes may no longer depend on simple straight-line speed. Drivers will have tools to defend through corners, brake later with more stability, or attack exits by shedding drag earlier. Every maneuver becomes a system-controlled gamble. Human input will remain vital, but data-driven decision-making will dominate racecraft. The era of gut instinct gives way to algorithm-assisted aggression. This change places enormous pressure on software development teams. Unlike traditional aerodynamic elements, which are shaped and fixed during wind tunnel testing, active aero relies on code, sensors, and predictive behavior. Engineers must write logic trees for every scenario: wet conditions, tire degradation, traffic packs, yellow flags. One flaw in the aero control algorithm could cause erratic handling or mechanical failure. That means the best cars in 2026 might not be the most powerful but the most intelligently coded. Driver adaptation will also be crucial. Max Verstappen, Charles Leclerc, Lando Norris, they'll have to relearn how to feel grip, because the grip itself is now dynamic. Imagine attacking a high-speed corner not knowing if your aero is about to shift mid-turn or trusting it will and adjusting your steering accordingly. The trust between driver and system will need to be absolute. For rookies, it may be overwhelming. For veterans, it will be a true test of flexibility and nerve. Pit wall strategy is about to evolve, too. In-race setup changes, previously limited to tire choices and fuel modes, will now include wing adjustment profiles. Do you run aggressive aero early to climb the field? Or conserve energy and reduce wing load for a late race push? Race engineers will juggle dozens of variables, all tied to live telemetry and sensor feedback. Race decisions will become more reactive and more vulnerable to error. One missed aero setting, and a car could lose balance for an entire stint. And then there's the spectacle. The FIA is betting big that active aero will tighten the field and boost overtaking. But it may also introduce chaos. Cars will look and behave unpredictably. Wing elements will shift visually on camera, changing shape lap by lap. Fans may see passes in unexpected corners and crashes in places where downforce used to save drivers. It's the most visible sign of F1's leap into a high-tech future. And with that leap comes risk, reward, and relentless recalibration. The 2026 engine regulations are not just an update, they represent a full-scale revolution that challenges everything teams know about power delivery and energy management. The internal combustion engine, once the heart of an F1 car, will now play a secondary role. The new rules limit the combustion engine to just 400 kilowatts, a dramatic drop compared to previous years, while doubling the electric motor's output to 350 kilowatts. That's a 50-50 power split between fossil fuel and electric propulsion, making hybrid technology the dominant force in performance. This fundamental shift forces teams to rethink every aspect of powertrain design. The smaller combustion unit must be lighter, more compact, and yet still capable of extreme reliability over multiple race weekends. Thermal efficiency is no longer just a goal, it's a survival requirement. But the true pressure lies in the electric side, managing high voltage, optimizing battery output, and ensuring seamless torque delivery. Teams must now become experts in both engine combustion science and high-speed electrical engineering. The battery, once a silent component hidden deep within the chassis, becomes a battlefield in 2026. It's not just about storing energy harvested under braking, it's about delivering power consistently over long stints, managing heat, and recovering energy at a rate that supports full throttle deployment multiple times per lap. To make this possible, teams will need to develop cooling systems that are lighter, smarter, and capable of surviving intense thermal cycles. Even the smallest miscalculation in battery chemistry or temperature control could result in performance collapse or, worse, failure. With the ban on MGUH, the exhaust-driven energy recovery system, teams lose a vital efficiency tool. In its place, the FIA is pushing a simplified hybrid structure, which places greater pressure on software algorithms and driver input to recover and deploy energy at precisely the right time. This change is intended to make the sport more accessible and sustainable, but from a technical standpoint, it throws a wrench into years of R&D based on MGUH integration. Now, every team starts with a blank slate, and those who misread the balance will fall behind. One of the biggest gambles in this regulation package is sustainability. The FIA's requirement for 100% sustainable fuel isn't a minor adjustment, it's a complete switch from traditional high-octane racing blends. These fuels must replicate performance while dramatically reducing environmental impact. But sustainable fuel tech is still in early stages, and suppliers are racing against time to develop blends that meet performance and reliability standards. If the fuel isn't optimized by 2026, teams could suffer power losses or reliability risks that skew the championship battle. Financially, the engine overhaul is a minefield. Power unit development is expensive, and although cost caps are in place, the reality is that large teams will always find ways to invest more strategically. The risk for smaller outfits is enormous. A misstep in powertrain architecture, battery cooling, or fuel integration could mean an uncompetitive car for multiple seasons. And because the 2026 engines will remain in place for years, there's little room for experimentation or slow adaptation. You either get it right from day one or you get left behind. At the heart of this engine revolution lies the future of Formula One. The FIA believes this hybrid-focused architecture will create closer racing, boost innovation, and align the sport with global sustainability goals. But it also creates the most technically demanding challenge in F1 history. The margin for error has shrunk. The window for dominance has narrowed. And the next world champion may not be the fastest driver but the one with the best integrated power unit, the smartest energy recovery, and the most bulletproof battery on the grid.